So I guess I'll go ahead and introduce our speaker. Um, I had the pleasure of meeting John Bittorf a few years ago when he helped out immensely with a couple of other sort of workshop people. Julie Lamberts was doing a benthic workshop out on the Indian River, I believe, and John went along to help out and observe things there. And then Rosie Martin had already done one event for us in Harrison Park, and she was all set to do another one, and her car broke down the night before trying to get here. And John filled in very, very well and took care of us there as well. So, but speaking to John with the kind of work he does and has been doing for a long time, I sort of thought that, there's some things that he was concerned about might be lost if they didn't have continuity with the kind of work and the data and the records and of former weather events and that sort of thing. And I thought, well, why not invite him to come and tell us about them so that we get that information, and then it's out there a bit more. And so I'm really delighted to invite John Bittorf to tell us about the water and the watershed that he looks after for us.
Big drink of water. Yeah, it is. Yeah, I should have put some in it. Thanks, guys. Just a few quick ground rules. In my line of work, we use a lot of acronyms. So just going to go over a few. So if I say CA, I'm talking about a conservation authority, probably ours. If I say CAs, I'm talking about the 36 conservation authorities in Ontario. If you're not familiar with a conservation authority, we're municipally created under provincial acts, but we're based on watersheds. So we're really unique in Ontario with this type of setup. So it gives us an opportunity to try to better protect people from natural hazards like flooding and erosion, and keep development out of floodplains, that type of thing. Another acronym I'd probably throw out there is M&R, would be Ministry of Natural Resources. You're probably familiar with that one. MOE, formerly the Ministry of the Environment, now Ministry of Environment, Conservation and Parks, so MECP. I tend to forget that one. And if there's any other acronyms I say out there, then ask them. Ask what it is, because we just assume when we're talking about this stuff. So very quickly, I want to show you the programs that I manage at our conservation authority. Essentially, I just call it programs underwater. It's pretty much anything to do with water is my program, with the exception of source water protection. That has another department with a very good team of people that help to protect the drinking water supplies. So there's three areas within my program that I wanted to talk about: dams, watershed monitoring, and flood forecasting. So I'll start with the dams. Just going to give you a quick introduction to some of the dams we have. We have 14 dams on our properties throughout the watersheds. 6 of them are Ducks Unlimited dams, so they manage those. Most of them don't need anything done with them. They're just operated as overflow weirs. And then we have about 5 or 6 that we actually actively manage every spring and fall, where we have to put boards in and take out again. The first one we generally put in every year would be one on Burford Lake. It's not a big dam. It's only a foot high. But to the people on the lake itself, it's important to get that one in to store enough water so they can have kind of an extended season throughout the summer with the higher water. They are constantly losing water through a big sinkhole, so it's not a lake that normally stays up. There's not a huge inflow of water to this lake, so evaporation versus rainfall determines how much water this lake will have. So we try to get that in quickly. We're actually going to go up there tomorrow and start adding 3 of the 4 boards. But it's just an example of where we try to help the community with these small dams. We didn't originally build this dam; we inherited it, but that tends to be the theme of all our dams. But just one of the ones that we look after. That doesn't like me. Owen Sound Mill Dam, you're probably familiar with that one. It's in the heart of Owen Sound on the Sydenham River. This dam can be fairly challenging. We try to put it in the spring. We need to wait for the flows to get down to a certain level before it's safe to start managing the boards. We used to our timeline used to be dictated by the fish runs and stuff, but the fishway got modified so that it could pass fish on lower flows. So now we're just generally we're trying to get it in before the long weekend in May. That was our target. Till a couple of years ago, we notified everybody on the pond that we were going to put this dam in soon, and they started notifying us that there's swans nesting where the water's going to flood. So that put a halt on everything. Swans are federally protected, so we needed special permission to flood the nest, thereby destroying the eggs. So we had to go through the process of getting that permission. We didn't have the option of not putting the pond in. We had to get that in. So we got the permission. We notified the feds, hey, we're going to try to move this first. They said, well, good luck with that. It never works. But this is the first year of COVID, so we're down there. We have pitchforks, have a team of guys with snow shovels trying to keep the swans away from us. So we're lifting the nest up with pitchforks. We put it on a plywood board, moved it up to the near shore, which was a nice wild area that wasn't cut grass and stuff. Slid it off, and then we managed to corral her back over towards the nest. She looked down. Ah, my eggs sat on them. So worked out. One egg did survive. We called him lucky. Unfortunately, he didn't make it through the summer, but it was a rare situation where we were able to do something everybody else said wouldn't work. So we still tried. We worked with the community. The last thing we wanted to do was just flood the eggs out or do anything like that. So now we have people on Swan Watch every spring on the mill pond. So they let us know when the swans show up, and they'll also let us know if they start to see nesting activity, and then we'll start looking and seeing if we can get the dam in as soon as possible. So if you're ever looking down at the dam, try to use my mouse here as a pointer. So here's it's a gate system, so we have to lower the gates to raise the pond. That can be confusing to some people. I always get an email back saying, I don't understand. But we lower the south gate first. It goes all the way down. You can see that in the lower one here. And then if we have the north gate up a little bit higher, that means we're trying to manage, but we're trying to make sure we're passing flow. We can't shut it off completely, but then we're going to be managing higher flow than normal. So I manage that gate to try to keep the pond stable. The only problem is when that gate's like that, we get all this crap and everything else seems to gather on that side because it can't go over the gate. It just floats to that corner. So our staff try to make a conscious effort to keep that clean, but it builds up quickly. So it tends to be one of the areas we get a lot of complaints on. If you're ever wondering if the pond's too full, that water levels are too high, there is one of these wing walls right by the thing there. So if the corner of the wing wall is right at the water level, we're good. If it's up where the water's touching actually the railing, we're probably in the high zone for what I'm trying to manage for. But the only thing to remember is this dam can overtop in a extreme event. So everybody upstream needs to remember that water level can go 2 to 3 feet higher. So we haven't had that in a while. I was worried we were going to have that this spring, but luckily the water got away. Bogner Marsh Dam, it's our dam number 2. It's not the main Bogner Marsh Dam. So when you walk in and see that dam at the end of the lane, that's not the dam that we manage. Ducks Unlimited looks after that. This is the one closer to Gray Road 18, and it's got a board system, and we generally it's one where the guys will drive by, drop a couple boards in on the way home. They drop a couple more in, so it's not something that we're in a hurry to get up, but we have to be careful we don't shut off flows because fish are spawning down below. So we have to make sure we're maintaining enough flow for that. Rankin Dam. This is the dam I call the dumbest dam in the world. It's formerly the system was you had to the dam's actually put down in a hole down and attached to bedrock, but it's in a hole of the riverbed. So the old system was the guys had to stack the logs all up and then jack them down. So you can see there'd be a lot of problems with debris and everything getting underneath, blocking it. We can't see what we're doing, so all kinds of problems with it. But we did about 3 years ago, we changed the system that when we pull the logs, we're leaving enough logs in that we get this little, there's a little bit of a head on the upstream side. So we're getting this little riffle going on. So the guys now can just set the logs in like a normal dam. So it's worked out well. We're waiting to get back there this year to see and make sure the high water that we had this spring didn't cause any problems. One thing with this dam is when the water's really flowing, downstream of the dam actually backs up water to the dam. So the dam's actually underwater, but it's not eroding. So I have a chart here that I just want to show you. Um, the blue line here is actually the lake level up at the was it Bruce Road 13 bridge, and the black line is the water level at the dam. So we have a sensor at both locations, and the purple line is a logger immediately downstream of the dam. So you can see when we're having our spring runoff, the water levels are almost equal. I'm missing data from last year. I just haven't put it in yet. And then I have other lines here, threshold lines of how high it can get. The green line is the actual top of the dam, the catwalk, and water has gotten that high before. So just an indication of how we try to monitor these systems and try to make sure we're understanding what's happening. Inglis Falls Dam, not a major dam. We throw a couple logs in every year just to make some kind of a pond, just to improve aesthetics a bit. But it is an old dam, and we don't want to put a lot of pressure on it by putting the full boards in. So this spring it was running over the overflow on this dam. So it had a pretty good flow in the Sydenham River this year. Clendenin Dam is upstream of Clarksburg. It's our only true flood control structure that we have. It's a dam that's designed to trap the sheet ice. So the pond itself creates a level of ice in the wintertime, makes a nice plug, and then any ice coming down the river gets caught up in the ice. So it prevents it from going down into Clarksburg and causing ice jamming and causing flooding. So it's worked very well. The only issue Clarksburg has now is they still get that frazzle ice. So that's that really fine ice that gets created on cold days. And it still goes through the system and still collects downstream of Clarksburg and then starts backing up water. So it's always something that the municipality has to keep an eye on. Watershed monitoring. So that's another part of my program. So watershed monitoring to me, it consists of a lot of different things. I want to collect culvert data. I want to understand how the systems are flowing through the roads and stuff. So we collect culvert size and type. Flow data, we don't measure everywhere, but if I have somebody describing the flow as good, lots, ponding, dry, still tells me something about the site in the summertime for base flow. Fish data, if they see fish there, that's great. Then we still want that kind of data. And some people they'll have studies and stuff, so they're collecting and identifying the fish. We have probes that measure pH, conductivity, dissolved oxygen is DO, turbidity, temperature, and water clarity. We collect that, especially when we're doing our water sample program, which is the next line, water sampling. So we actually grab samples, send to the lab. Benthic samples, I'm going to talk about that more later. We do that. Groundwater monitoring, we have wells throughout our watershed that we're monitoring water level plus water quality within the wells. And then my flood forecasting program requires a whole lot more data from the watershed. So rainfall, snow water content, water levels, soil moisture. So all that stuff we're trying to collect. And you're probably thinking, well, what do they put that in? So we have thought, like 20 years ago, we put together this amazing little database. I know it looks scary up here, but it's a relational database built in Microsoft Access. So you've probably heard of that software. And it's all set up to work by the station location has coordinates. So anything that happens at the station, we can throw on a map anywhere. We have what I call field parameters here, but that's a site visit. So every time we have a site visit, it's tagged to the station. And every site visit, you're there for some reason. So you might have been there to do a benthic sample, water samples, or anything else. Anything that we do at a site, we can put into the database, and it can be summarized by the station, by the municipality, the water course, the subwatershed, bigger watersheds, subbasins like Georgian Bay and Lake Huron. So it's an amazing tool that we created a while ago, and then we started populating it. And by populating it, we went nuts. We have over 11,000 stations in the database. A lot of them were pre-programmed, so we knew we wanted to tag the stream watercourse mouths, and then any crossings that were on the maps, we tagged ahead of time. That way, if anybody had data to tag to put to that location, they just had to click on the map, get the ID number, and went right to the database and started filling it in. POIs, that's point of interest, so that could include springs, sinkholes, shore wells, tile outlets. So anything that was in the watershed that was kind of an interest to somebody like me that just wants to know where those things are. So road crossings and culverts, we have over 5,000 in the database. I didn't do all this. This is summer students recording this stuff, and this didn't get made overnight. It took about 5 years to actually get to this point within the database. We actually had a youth program at our office where we had kids for about 2 or 3 weeks, and exchange students, and they could hardly speak English, and I was having them put these dots in the database for me. So it was quite a collaborative effort to try to build this. Base flow data. So if you're describing the data at any of those sites, over 8,000 sites with some kind of a flow description in the summertime. If it's flowing, then I want to know its temperature. So we take both manual readings. We also have data loggers out there. So by having the temperature, we can classify, and the air temperature, we can classify it as being cool, cold, or warm. So that can kind of describe the fish populations you might see in that creek. Being cold or clear or cool, it could mean it's a fairly healthy system. Some warm water systems can be healthy depending where they are, but generally, if it's flowing from a spring, it should be staying cold for a long time. So that's the goal of keeping the watersheds healthy. Fish data, over 6,000 sites with some kind of a fish data description. So a lot of data. So it's really good that we had the database ahead of time to absorb all that stuff. So on to water sampling. We have 35 sites within our watershed that we get some kind of a water chemistry description. So the Ministry of the Environment, we share a program with them. 10 sites we do with them. We collect it and we send it to their lab, and they do a nice sweep of water chemistry and heavy metals and stuff. And then we have our own 25 sites where we're doing a much reduced sweep of just the basic nutrients. So things that are important to us that kind of feed into our watershed report card. And I'll go to that in a second. So this map is online on our web page. You can just click on a dot. It'll either summarize the data or it'll take you to a link to help summarize the data. We have 4 different parameters there that are generally probably the ones of interest when people are thinking of water quality. So just toggle those on and off. Don't use your cell phones to look at these maps. You need to use something with a bigger screen. It'll drive you nuts trying to navigate with a cell phone. But it's the same theme I have with a lot of my stuff that's online. So benthic invertebrates. So there's the critters that live in the stream bed. So they're generally larger than 0.5 millimeter, so larger than 500 microns. It could be crayfish, it could be aquatic worms, but for the most part, it's insect larvae where their life cycle, part of the life cycle is the young are growing up in the streams, and then they emerge out, fly around, lay their eggs, and start all over again. So this is my poor daughter on Bring Your Child to Work Day. So I brought her to work and made her work. So she's doing the sampling. So it's an easy thing to do. You just kick up the sediment and try to capture it with the net. You don't have to get everything. And then you take the sample back to a nice quiet place and you start picking the live bugs out of it. So most of the time it's a lot of fun. Then we will put those bugs into a preservative, alcohol, and then we'll identify them that winter or whenever we get time to do the IDing. So I don't know if she'd ever come back out and do this with me, but she thought it was cool enough when she saw me practicing this that she took a picture of it and shared it. So this is like 15 years ago. So just so you know, we do our own in-house identification of the insects that we collect. That's not common amongst conservation authorities. Most of them send them out to a private contractor. But we were doing an index where we needed to be better at this type of identification. So we self-taught. It was a challenge when we started. We didn't have Google, so it was really hard to find material. And once we could start Googling it and saying, okay, just put the species in and see what comes up, then we were able to really put some keys together ourselves and focus on whatever was normal to our area. So we were trying to make sure our keys weren't including something from California stuff. Um, so with COVID especially, we're trying to transfer that knowledge to other staff. So we're thinking, how can we teach each other to look through a microscope and have me try to point something out? So we come up with the idea, well, let's order a microscope with a camera. And then with the camera and the video, we can do Teams or Zoom, and I can be doing the microscope stuff, and the other person could be at the other end going through the keys and learning and listening to me and doing all that. And then it came up that why don't we just share that to everybody? Anybody can watch. And if they're interested, then they can watch this and they can learn how I cheat. I do a lot of cheating and sometimes that offends people, but I'm trying to get things done and get things done in a hurry. So just a quick video of one of our little sessions. We'll just see if it works. He's got for caddisflies, he's free living. The back of his thoracic segments all have plates. So there's 3 of them. And when we look underneath him, we will see these 2 plates kind of right there. So we have those 2 plates and the back's all 3 plates, and you know he's a certain group. And then we have keys that take them down to species. So the genus, the name genus keeps changing in the literature, so I don't, they used to be Hyperpsyche. So this guy, that's interesting. Well, of course, he's a 13-year-old sample, so light brown, he might have been darker before. So he's got that definite center spot, and then he's got another spot behind him, so right away we key out to that picture key there. I try not to say names. Sheet, I just have a circle with the number beside it, so it's 287. Everything's numbers. The central circle. I can have with this genus, I could have up to 5 different species in the same sample. So I've spent some time just learning them. So again, I got another guy here with back plates are all 3 are there, but he's got a little notch on his nose. So you're looking at the nose area, and you'll also see on the first thoracic segment that corner setae is usually quite long. I don't know if you can see him on that one, right? There it is, yeah. And he will not have those plates underneath. Or if he does, I got something new and different. So this guy does not have those plates. And there's a couple other features here, but he's Trematopsyche. So unfortunately, I don't have keys to take him down to species. I just have the genus level. Well, this is Hyperpsyche. Oh, sorry. So yeah, so that by doing it that way, Elaine's really learning in a hurry. She's the one that was managing the keys and managing the mouse, and I was just trying to describe to her what I could see. So it's really because she's not in the same room. So it's kind of a unique situation with that, but it turned out to be really good. So other monitoring we do, groundwater monitoring in partnership with the Ministry of the Environment. We do 10 wells. So you can see they're fairly widespread throughout our watershed. We tried to target different aquifers, like different regions. The wells are not intended to monitor a problem. They're trying to monitor ambient conditions. So just what is normal for that area. So again, there's loggers within the well. We download those regularly, submit those to the province. And then every fall we do water sampling. So it takes a while to do the sample. You have to pump the well for at least an hour, and there's a lot of water that we need to pump out before we can take a sample. So it's a slow process. So um, if you like watching water run, then that's a good job for you. So with all that data that we're collecting, we're not the only CAs collecting data. Everybody's trying to collect data. We came to the point that we wanted to start finding a way to report the data to the public. So back in 2008, the CAs were all playing with the concept of a watershed report card. So in 2000, in that year, we all published one. We all did it different. So we weren't very compatible to compare things next door and stuff. So after that, we all got together, um, trying to herd cats is what it was like. We got CAs with all this crazy data that they have, and they want to use it. Everybody has data, they want to use it. And then you have these other CAs that really have nothing, and they want to play the game too, but really hard to come up with a common ground between that kind of range of expertise. But we got committees together. We sat down, and the goals were to come up with something that everybody could do. At least most people could do, so we could all be a consistent watershed report card. So we followed 2008 up. Every 5 years. We do a report card, and I'm just going to go over the new format that we came up with. So watershed report cards. Why watersheds? Well, we're a conservation authority, so that's what we do. So that kind of was the driving factor for us. But watersheds are a definable area. Everything that drains out one outlet is a watershed. It can be any different sizes, but that's the general quick and dirty definition of it. So watersheds produce water, and when you have water, you can sample it and describe it both chemically and biologically, whatever can survive in it. And watersheds will show stress. So if you're having land use changes going on in the watershed, developments and stuff like that, the water coming out of the watershed will show it. So it will reflect change. We had all kinds of things we could have tried to classify. Um, and I'll tell you that the bigger CAs, they had all this stuff. The small CAs really struggled. So we looked at something like forest cover. That's data that's provided to us from the province. So everybody had that. Wetlands, same idea. It's an area layer that the province can provide. Benthic, over half the conservation authorities were playing with benthic, so they were willing to give that a go. We were all doing water chemistry sampling in partnership with the province, so we had that type of information. E. coli was not part of that provincial data set, but most CAs were adding that to their sample anyways. It used to be in the data set from the province, but after Walkerton happened, then the province dropped that from their sampling protocols. So those were the key features that we all thought we could do commonly. So the first thing to do was to find a threshold that you wanted to match or meet. And fortunately, Environment Canada put out a series called How Much Habitat is Enough? And within that series, they identified forest cover. If you had 25 to 35%, you were in good shape. So that helped us. We had a target. Forest cover is available digitally. We can cookie cut it with a watershed layer with the GIS software, just special software that just works that way. It's not really a watershed feature until you cut it with a watershed. So, but it works that way. It can change over time, but it's slow to change as we get updated aerial photography. It takes a long time to get that new forest layer created. It's a lot of hand tracing of polygons and stuff. Um, and if you're planting seedlings, seedlings don't count as trees until they're actually trees. So it takes about 25 years for a seedling to actually be acting like a tree in a ecological fashion. Interior forest, same idea. It's basically you remove 100 meters of the forest edge, and everything left over is interior forest. Environment Canada gave a target of 10%. Everything's pretty much the same as the forest cover. It's available digitally, and everybody could probably do it. And then riparian area is forested. So riparian areas we were looking at was 30 meters beside a water course. And if it was forested, that's good. So we had a target of 50% we were trying to hit. Same idea. It's all available digitally, just like the forest cover. The one key feature about this, it's one of the main focus of a lot of stewardship programs, is get the area protected and get it planted in trees. So by looking at the targets, we put all the targets in kind of the B category, and then we built an A to F scale around that. So if we were meeting the target, we were a B. If we're exceeding the target, we're an A. Um, I was never worried about Fs because we're not that bad. And then we would average the scores together to come up with a grade. So this is the forest conditions map that we have for our watersheds. You can see the dark greens are considered excellent. Lighter green is good. We had some those. Yeah, so we had some poor areas, and that's mostly agricultural areas where the tree cover has been removed, but it's really hard to balance cash crop versus tree cover. So it comes down to certain priorities in that region. So overall, we scored fairly well. Doing a water scoring, the water health scoring. Same idea. We're using water chemistry and E. coli. They're easy to collect. You just go grab the sample. It's not cheap though. It costs money, and you actually need a lot of samples to be able to characterize a watershed. So you just can't take one. You got to take 30 or 40 over a 5-year span. So it's that's the type of expense you have to fork out. And the good thing about water chemistry, we had a total phosphorus target. Most people relate to total phosphorus. They know it relates to algae blooms and stuff like that. So the province has some objectives, so we could use a scoring system around that. And we had the E. coli target for swimming, which was less than 100 count per 100 millimeters or milliliters. So we were using those as that B category. And benthic sampling, we actually had to go backwards with this to meet the criteria. We were already doing better than what they wanted. So we were doing it. Required family level, which was higher up than what we were doing. So we could easily go backwards with our categories. Benthic's easy to store, so you can get them in little vials and you just store them until you can use them, or you can keep them for reference for future in case somebody thinks you're lying. And then there's different indexes that you can put it through, and everybody in the group was familiar with the Hilsenhoff family biotic index. So it's called modified because they added more bugs than the original scientist said to use. But it still works. So what it does is it scores the family level from zeros to tens. So zeros would mean really clean water, whereas tens are really bad. So if you're kind of in the middle, below 5, you were doing pretty good. So again, we put the categories all in the B grade and then work from there. Everything else is kind of made up. So it's as long as we were making sure we were meeting any thresholds that were published, we were good with that. And then we averaged out those categories. And as you can see, we scored well again. And we had no poors. Everything was fair or better. So from a benthic perspective, or from a water quality perspective, our watersheds are pretty good. Now, it doesn't mean we don't have problems. There doesn't mean we don't have isolated spots, but in general, the watershed as a whole at the mouth of it is fair or better. So, and then wetland cover. This was something we added in our last report card, but it's Environment Canada recommends 10%, and so same thing. Everything's digital. We just cookie cut it, and we put the grade in the middle of the B category, and then created A through F around it. And for our watersheds, a few surprises. The Rankin system, Potawatomi River, Indian Creek system, all scored excellent with all the wetlands they have. But the Waterton Creek and Johnson Creek and Little Beavers, some of the small watersheds scored poorly. And we figure that was more due to the gradients of those watersheds. They just never really had a lot of wetlands features. They were just such high gradient and flashy that they didn't have that kind of storage within the system. And if you want to see other Conservation Authorities report cards, you can go online to Conservation Ontario's website and just click on a watershed. So that gives you a quick view of most of the conservation authorities in Southern Ontario. There are some in the northern parts around North Bay. So real quickly, I want to go into our flood forecasting program. About 8 years ago, we did strategic planning, and this was an area that was identified that we needed to do better with. No one defined what better was. They just said you need to do better. So, and they gave me no money. So, what I do as I go through this, you're going to see a theme of I am cheap and I use free stuff. So my kids call me cheap. I say I'm economical. I define cheap as somebody who won't do it because it costs money, whereas I will do it, but it'll be cheap. So that's the defining thing I do with that. So there's lots of free software that I use that I've got listed here. I don't know if I can get a mouse to work. Lots of stuff online I can download or use for free. And then also Excel, Microsoft Excel and Access, both come on our work computers anyways. So I consider that free. I know we pay for it, but everybody has it. And then a lot of Google stuff. Online networks that I can tap into. Environment Canada has the Weather Radar networks. They also have Water Survey of Canada. They're the ones that do the professional stream gauges that are all through Canada. Over almost 50,000 stream gauges that they have. So quite the network. And then Environment Canada has some volunteer weather stations, plus places like Wyerton, where they're part of the Environment Canada's program. Other stuff that's out there, so other weather station networks that are online, Wonderground, there's Tempest, there's WeatherLink, Meso West, and those are all ones that have automated weather stations reporting online. So the data is refreshing less than 5-minute intervals. And so that's really powerful stuff. Coco Rask, that's actually a manual gauge. So that's a network of volunteers. And when you have these, you report every morning, usually the same time. Anytime between 7 and 9:30 is good. But you'll report how much rain you received or whether you had none. So it's good to report it every day. Challenge with it, it's like a paper route. So it's something where once you commit to it, you're kind of stuck with it. There are ways that you can report multiple days at a time, just in case you're away. So you don't lose that data. You can also measure snow, measure the snow melt and everything else in it. So it's a really, really nice network if you want to participate. For our watersheds, as long as you're not knowing sound because it's saturated with these things, we will provide the rain gauge if you sign up and commit to do it. But give me time. I'm all sold out right now, so I have to order some more. But we will commit to this program, and we do want to see volunteers participate. So it's a nice rain gauge. It's a 4-inch top. It flows into a cylinder. The cylinder has millimeter markings on it, and you read it. If it has more than an inch of rain, it will overflow into this tube. This tube will take 11 inches of rain. I never want to see that. I tell everybody if I got 4 inches, I'm calling in sick. I'm not going to work that day. But just think about it. Texas will get this filled every year. Somebody in Texas will have this filled. That's how much, I really never want to see one of their storms up this way. I just don't know how they deal with it. It's just nuts. So if you're interested, let me know. There are pamphlets up here to sign up for it. Back to the show. We have some hobo units out there. The city of Owen Sound has a hobo unit on top of the water treatment plant. They're usually a more sophisticated unit. And if you have that, you can share the link with me and I will put it on a map for everybody else to see. And I will steal their data too. So for snow data, NOAA makes some wonderful products that are available online. And I also use webcams. Anywhere there's webcams, I try to use those to see how much snow's in the area, maybe if it's raining. Some people have webcams along the shoreline. So when the high water was high, I was using those to see how high it was, or if something, with the wave action, seeing what was going on. So that's online stuff that I can tap into. Now we managed to expand our own network as cheaply as possible or as economically as possible. So we have a whole suite of different types of units that we have. We have a couple of units that are transmit to the satellites, and we get the data back from NOAA through their websites. We have a unit where we have a phone modem. We still have an old phone modem that makes that phone modem sound on my desk, and it calls it every hour and grabs the data from the logger that's there. We have these AquaSwift units. There's a little one right here, and it's a cellular transmitter. A little solar panel on it keeps it going, but it's just transmitting water level and water temperature. $300 for the unit and $300 a year for the subscription. So that's very economical. We also there's another product, Solence. Solence is into groundwater supplies. So I took groundwater supplies and turned them into stream monitoring supplies. They transmit, they email to me, but they need other data like air pressure to correct the water pressure. So their absolute pressure, so that's water and air, and then I have to subtract the air pressure off of it to actually get the water level. So that's a little more complicated, but it still works. They weren't too bad for price. Other stuff that's out there, the Cocoa Rasp ones, I really use those a lot. The Wonderground network, of all the networks I'm going to show you, Wonderground is the best to put your data on, just because it's easiest for me to steal from. So, but it's got some really nice products. And then we have a more sophisticated GOES system. It's actually in the Arboretum at our office. It's what I'm going to say is probably the only professional rain gauge in our Grey Bruce area. It's what transmits to the satellites, and we get the data back from the satellites. So we take all the data we can find, and it's just not for me. I share it to everybody. So if you're into rain gauges or anything else like that, go to our website, check it out. We got these really ugly maps on there, but they're maps of links. So if you click on it, you just follow the link, and it'll take you to where I'm getting the data from. So snow data, as I mentioned earlier, this is on our website. We have different products there. So we have the red dots, the blue dots, and the orange dot. So the red dot will take you to my data. This is the data we collect when we're in the field every twice a month through the wintertime. We collect snow data. And then it goes into a database. The database talks to Excel and creates this combination chart. So the orange line is average snow depth. The blue line here is average water content. The water content's what's important to me. I need to know how much water is out there. And then the bar graphs are the sample that we took. So it gives you a sense of how we are compared to normal or average. And for this was in 2020, we were actually carrying a heavy snow load into the spring. And this really helps our forecasters and me visualize how much water we have above average. So how much extra we're dealing with. Doesn't mean we're going to have a bad spring, but the potential's there. So just show you how we collect the data. We have a specialized snow tube that we stick in the snow, get a core, measure the height, and then we take that core and we weigh it. And the spring that we're using, the scale, is calibrated to give us water content. So it'll just automatically tell us that that's got 2 centimeters of water content. So that data all goes into an Excel spreadsheet or an Access database, feeds it into Excel because Excel is good at charting, makes the chart. Excel also has a feature where it publishes it. We publish it into a Google Drive, and then that's shared between, we share that out to the public from that. So when you click on our link, you're just seeing a Google Drive file that's shared. So it's not interactive, it's just an image. So NOAA, that same NOAA that map, the yellow dot, takes you to a NOAA site where I've kind of focused in on our area. And with that, you can actually change what you're looking at. So in this situation, we're looking at water content. You can flip that to be snow depth and everything else. So this is what um, they interpret the snow to be based on radar and everything else. So it's kind of a modeled exercise. So they can undervalue our region because we get these snow squalls that come in under the radar. So there's quite often they may be underestimating, but it's still a great little product. So the one down below is actually I've turned on the snow melt feature, and at the time of day and everything else, I can see the active snow melt that they're modeling. Doesn't mean it's perfect, but it's still a nice visual tool for me to look at. And then you can actually go way back in time with this one to when they first started doing all this work. So you can go back 10 years and see what that winter was like, and you can really play with it. So it's a nice product. It's free. I still haven't found another CA that's using it. They're kind of doing their own thing, but I keep trying to say this is great. So within that product, they have these little dots, or they call it stations, that they're saying they're using to help calibrate their model. And a lot of those stations are CocoRAS gauges. So anybody that has a CocoRAS gauge, these guys are modeling for your site. They're modeling all this snow stuff, and I'll just show it to you in a second. So there's other older networks that are feeding into it. It's an American product, but it still works good for our region. So they produce 8 charts. So if you're really into snow, you can go through these charts. This first one's more interesting to me because it shows water content. Snow density tells me how ripe it is, so how close it is to actually releasing water. Snow depth, and at this site, the CocoRAS person was measuring the depth and reporting it. So you can see how it's lining up with their model. And then snow melt is the red line, but it's not doing anything in this image. But they also, in this next screen there, they're showing some forecasted snow or rain, and they're also hindcasting what they think happened based on radar and everything else. So really, really good tool to work with. The hindcasting, especially when they start trying to correct the data, and then I can take that hindcasted data, shove it into my models, and see how my models perform. So it's a really nice product to actually piggyback on. So then there's more stuff. So if you're into snow, have a look at it, because there's a lot of stuff that goes into their modeling for them to actually determine the snow density and when it's going to melt and all that stuff. Now, what I like is I can just click on the one lookup box that's there, and I can just go down and I can pick whatever file I want, hit refresh, and it downloads. And if you're a little savvy with the internet stuff, you can actually set it up to automate that. So I capture both plot 1 and 2 because one's snow melt, the other one's rainfall. So I put those together to get a product that's usable. So here's the 2 files. I put them together in Excel. One part of it feeds my flow models, but the other one makes this messy graph, similar to the one we saw on On the NOAA site, the blue line, heavy blue line is water content. So we're having a melt event. Water content's actually shooting right down to zero. So the snow's all leaving. The red line is the snow melt value that it's coming up. The green are rain events. So just because it's raining on snow doesn't mean it immediately goes into runoff. So it's just adding water to the snow content, just building up water content within it. But as the snow disappears, the rain just adds to the runoff directly. So this lucky that was only about 1.5 inches of snow water to start with. If that was 4 inches, we'd be in trouble. Anytime we get rain at the end of a snow melt, that's when we have flooding. So that's just a normal snow melt goes away nice, but it's the rain. It's how much rain we get and when we get it and how hard it comes. And then of course, the peach area is the forecasting, and it was forecasting just like Gray Bruce. We always get more snow after. So just a unique situation that I grabbed and kept as for display purposes. And then we publish that chart into a folder that our flood forecasters can see. And then, as I mentioned, we feed it into my flood models. Get the mouse to work here. So the purple line coming from the top down, that's the rain snow melt. So you can see the axis over here is inverted. It's just telling me how much rain or runoff I'm getting. And then the bottom axis is the flow, and it's on this side. So the blue line is the actual flows, and the green line is a modeled flow. It's the same model, but it's running on different saturation points in the watershed. So green means it takes a lot of water to get it going. Yellow would be kind of a medium saturation, and then the red is it's saturated and we don't need any more rain. So generally, a spring snow melt will just do what this just did. Is it's usually just above the yellow line, as far as my model works. If the same amount of rain hit us in the summertime, we'd be lucky if it hit the green line. That's the difference in the seasons. So springtime is our worry time. We're always at a point in the spring sometime. If we get the wrong timing for rain, we're going to have flooding. Just when the ground's saturated or semi-frozen, all that stuff. So we're always susceptible to flooding in the spring. But as long as the weather doesn't hit us wrong, then we get off okay. And my little guy over here, George, he's famous for quoting, "All models are wrong, but some models are useful." So just keep that in mind. So in this case, the model is useful. It's the timing, everything about the peak is, it's within reason within the model. It doesn't always work out that way, but it's nice when something does work. So when I go back to mention this one earlier, this watershed conditions map is on our website. I shove everything on there. I used to just keep it in-house for me, and I thought, everybody might like this. So I put it on our website. Main thing with this is open it on a large screen, shut off all the layers so it's not as clustered. And then you can toggle through the layers and just look at what you want to see. Again, it's a map of links. So whatever icon you click on, it's going to open up a box at the side and show you some links. So here's a webcam that upstream of Terra. This is one of our own webcams. So this is a cheap internet camera, outdoor camera, running off of a hotspot that I created with my wife's old cell phone. So it reports every 15 minutes. And I have that in several other places. So never throw something out, right, guys? So it's a really good tool. There's a couple links there. Some of them will just take you to that image, and other ones will take you to websites that you could actually look at the last month's images, all in kind of a reel, so like a video. It's pretty neat. I also grab, capture, steal other people's stuff. So here's a private webcam up at Big Bay that they're sharing their images online. So I put it on my map. Here's our webcam at Allenford. Same idea. It's running a hotspot from a cell phone. Unfortunately, the 3G networks going to 4G is going to gonna cripple me with that. I gotta change things. We have MTO has webcams out there, so I try to capture all of theirs on the map. And then Gray County has some nice webcams. There's some ski hill ones on there. There's what if I find a webcam online, I'm putting it on my map so everybody can just go to one spot if they want to spy on people. So Water Survey of Canada, mentioned them before. That's the federal government and all their stream network. So they're on here. They're all the red stars. And then there's Collingwood, which is actually the lake level. So it's their gauge for the lake level in Collingwood. I also have Tobermory on here. I just don't have it on the screen, and Godrich. So if you want to click on those, you can just come to my map. And when you click on it, you have to agree to a waiver, but it's just saying that you understand this data is provisional, and be careful with it. So for them, it's they show water level is the green line, and then they do measurements every so often, measuring discharge, so they can generate a rating curve, and then you can feed the water level into the rating curve, and that'll give you a discharge for the whole curve. So, and it's nice. It's interactive. You can go back in time. You can get the whole year's data showing on one screen. This is our go-to when everything else is falling apart and failing. We know these guys will have it. What they're missing that I want to see is rainfall. I want to see rainfall on the same chart that I see the discharge and everything else changing. So this is the maps, the charts that I create in-house. It's all automated, but it posts charts every hour, but it's a 3-day window of what is going on with that sensor or that site. And there's different, because they're all different sensors. They have different capabilities. So just to let you know, when you click on a dot, every chart could be a little bit different. Always look at the date stamp on the chart, though, if you want to know if the site's actually up to date. There's no guarantee, because these are inexpensive things, so they do fail. So here's an AquaSwift one we actually had up by Oliphant. When the lake levels were high, we were trying to track the high water levels. The lake's actually on the other side of the road, but the lake was already back filling into the culvert, so I was able to safely put a logger or a sensor on the culvert side, on the upstream side. So it worked quite well. The green line in the chart is the water level. You can see how, based on the wind and everything else, the water levels would fluctuate at that location. We put on some historic lines on here. So the orange line was the highest level in September, because this is a September chart. I put that on there. And then the red line is the highest ever. So that was October 1986. So that was the highest level that's along that shoreline. The shorelines are funny because each reach is a little bit different what their highest level was. So you just can't say Lake Huron, this was its highest level. It's where it hit the shore with the winds and everything. There's all different levels that are used for regulation purposes. Here's another AquaSwift unit that's on a small stream, but it's in a floodplain. So what it's reporting, the green line is the water level. I don't have rainfall with that, so we show the water temperature. I hate to waste an axis on a graph, so I always put whatever's available that might be of interest to people. So it's showing the water level. It's showing the bottom of the bridge. It's showing the top of the bridge is the red line. And then this is also an area where two county roads come together as an intersection, all in the floodplain. And so I have the elevations of the county roads as well. So if the municipality is wondering what's going on with that road, do I need to get out there? They can look. They can look on my chart and say, is it recent? And then see how high it is. So if it's over the red line, we know the road's flooding. They probably need to do something. If it's over the purple and the black line, then you phone in sick. So this is using the Solence product. So this is the one that's for groundwater that I've changed over for using with streams. So this one needs air pressure to correct the water level. And because I'm grabbing from one of those Wonderground gauges for the air pressure, I can also grab its rainfall. So the closest weather station to it, I put it together. And so you're seeing the green line is the water level. The red bars are rainfall per hour. And then the blue is the accumulated rainfall for that whole 3-day period. So that means a lot to me because I'm looking at what's happened over the last 3 days. Is the watershed saturated? How bad can it get? And also we're watching for how quickly the watercourse reacts to the rainfall. So if it's immediate, then that's a pretty flashy system. There's going to be no warning for that system if it gets hit. Whereas if it's a bigger system, we may have time to warn the municipalities, hey, this thing's climbing fast and we think it's going to exceed what you're used to. This is actually a sensor on Bothwell's Creek, if you're familiar with Bothwell's. And this is Big Head River. So this is the same site as one of the Water Survey of Canada sites. So a federal site, we're grabbing their data too. Same idea. There's two charts I generally create. One's I call low flow and one is high flow. So low flow, we put in a line for what is the average lowest summer flows. So that's kind of my threshold for when we go into a level 1 trout response. So if it's staying below that, then we know we may need to get our low water response committee together and talk about how dry it is, what kind of messaging we want to put out to the public, and then whether or not people will voluntarily reduce their water intake if they have any water intakes happening. So we're talking golf courses, quarries, places like that, orchards, anybody that's drawing from the stream system. Not talking about people watering their lawns. That's usually the calls we get. My neighbor's watering the lawn. What are you going to do? So the green line is flows. We do that, and then the dark blue line is the accumulated rainfall. So you can hear we had over 40 millimeters of rain, and that triggered that jump in stream flow. I can also see how quickly the Big Head River responds after a rain event. Looks like the blue line ended about here, but it's generally within a couple hours it starts peaking. Same location, because they're doing water level measurements and actually converting it to flow. We can grab the water level data too. And what we have at that location, we have the elevation of the lowest point in the road in Grey Road 12. So we know where the road would overtop. We have the elevation of the top of the bridge. So we know when the bridge is compromised. And the orange line is the upstream neighbor has a lane through there that goes to the house. So when we're in a flood situation, that person could be cut off from any kind of emergency vehicles or just them trying to get out just because they're flooded. Same idea now with the Google Maps. I put on all the rain gauges and weather stations I can find. That includes the CocoRass stuff. You can click on those and see what they look like. For example, Environment Canada, if you went to Wyerton, this is the type of chart you would see there. They usually show a monthly summary, but there is a button you can push and you can get the whole year's data, daily totals from Environment Canada. CocoRass, again, follow the link and it will show you at the very least a monthly summary, but they have beefed up their website. So now they got some really cool things to look at. And then you can toggle through some history. If you really want to go to one, the site number 5 is the longest running CocoRass station in Ontario. So it has a lot of history there. I'm not going to say it's my house. I was the first one to sign up in Ontario. So CocoRass maps, so just gives you an idea of the coverage we have and the type of data that can show up. We have 3 or 4 people in Owen Sound already that are reporting. This dot here just north of Owen Sound, that's actually neighbors. So one's overlapping the other one. They're competing. So kind of fun. So the more of these types of units I have out there, the more information I get from them. They're really good because if that one's reporting, the automatic ones are reporting a lot of water, I can look at the nearest CocoRass and says, is he even in the right ballpark or is he broken? So these you can't make a mistake on. Those ones, there can be issues. Hobo Link, so that's the Hobo ones, a little more sophisticated, but they do have a nice website that you can make some neat little graphs for people for interactive graphs. But it's something where they have to share it. WeatherLink and Davis. Davis Instruments is the product. Um, you have to make a free account if you want to see more. So they tease you with a little box at the front, but if you want to go to the bulletin and see more, you have to make a free account. But then you can see everybody's data. So that's the type of coverage we have from WeatherLink. Not a lot, but just a few. Meso West, it's an American product. It tends to bring in some of the older networks that were around before these ones that I mentioned. And some of the graphic, everything's kind of really dated, but it's still, the data's there if you really want data. So you can see there's a few stations in our region that are reporting there. Wonderground. So Wondergrounds, it's the top of the line one. It's one where I would encourage everybody to report to, even if you're reporting to the other networks. Try to report to Wonderground. It produces some really nice graphics, easy to understand. They store your data very nicely, and so you can always go back and get the data. So it's a good site. But what they do that's a little different with their rain gauges, they have a map online. This isn't mine. This is theirs, where they're showing real time how much rain we got since midnight. So for when I'm doing flood watching or watching a storm go through, this is what I'm watching because it's every few seconds it's updating. So and then I can also click on the dot, takes me right to the station. And I can see what's going on with it too. Sometimes station shows a lot of rain just because it's rattling in the wind. It's just shaking. But in general, this stuff's good. But it's toys. So that's the one thing you got to always remember. And it's also for private use only, personal use. I'm okay to share the links, but I can't really, I'm not supposed to summarize the data and share the data. I'm not supposed to make money off it, that's for sure. So what I do, I steal all their data, put it all together in a database, all those different networks, and then I generate my own map that's similar to the Wonderground one, but this has to update hourly. So it's very helpful. So in this case, in 2023, I had 122 stations reporting. So we're still around that number now. We lose a few, we gain a few. But it's powerful, and I've made this one that it's actually showing the last 24 hours, not everything since midnight. So it gives me a better picture understanding of what we received. I don't like radar. Radar tells me yes, it rained, but radar can tell me it rained hard, but it can't tell me how much. So these are telling me what's actually hitting the ground. So it's really, really valuable when I'm trying to decide, okay, did they get a lot of rain or not? So a lot of times I might see something going on in one pocket. We might have a thunder shower, and I will email the municipal staff, say you might want to go for a drive up to Big Bay or something. So we do share this with municipal flood contacts, but not to the public because of that personal use criteria. So because I have all that data, I do summarize it. I do generate these monthly rainfall maps. They're online, and you can toggle through the different months. So when I'm starting the new year this May, I will start a whole new map. But it gives you a good sense looking at this, who got rain and who didn't. The farmers really like it, the agricultural community. But you can click on the dots and take you to the link of the weather station if you want to see whatever was actually showing there for rainfall, or if you just want to know more about that site. Oh, along that same lines, because I'm also grabbing air temperature, I'm calculating crop heat units and doing the same kind of map that way too. So the agricultural community can look at my map, and they can get the crop heat units from it. Also using another free service online called Spot WX. And if you have coordinates for anywhere, you can get a forecast for that spot. So I've generated forecasts for these circles on the map, so I can kind of get a sense of if the rain's coming, what areas are targeted to get it. So one thing that really helps me with this is this Get Real Time software. It's a free product. Gentleman, the states created it, and basically sitting back and saying, "I'd really love to have something do all these things." So it will grab radar data and convert it to rainfall. Um, it will grab all the stream flow data from the federal government. It grabs the forecast data. It grabs a lot of stuff, and then you can also feed in your own data into it. Very slick, and it runs very quickly, and it's free. So it grabs all that underground data, which we have out there. So we have for our watershed, we have almost 80 underground stations that this software is grabbing the data for. Meso West, it'll do that, Spot WX, and the radar and the stuff from the flow data from the federal government. So the software goes, grabs it, sticks it in an Access database. So everybody knows I love Access now. And with Access, you can make your own charts if you really wanted to. They're really poor, but you can feed it into Excel, which makes nice charts. And then those nice charts I can publish and then put online. Uh, but what I really like about the whole process is it can grab my own data in text files or whatever format I put it in, and it'll just bring it right in as long as I've set it up to do that. So it's free. So when I mentioned the radar capture, it allows me to draw my watersheds in a radar image. So it will grab all the radar data within that watershed every 6 minutes and calculate out how much rainfall the radar data said was in there. I can also create a single point over top of a rain gauge, like an automated one, and it will grab the radar data over that point. So a virtual rain gauge over top of a real rain gauge. So then you take the real rain gauge and correct the virtual rain and then apply it to the watershed. So, and it does that all in real time. So I'm just going to play a video just to show you how the screen looks when it's doing it. So if a red dot comes up, that means it's that location is grabbing data. Oh, no sound. So as that image is going across, that software is grabbing data. So it's taking the color that it's getting from the radar and converting it to rainfall. One thing to remember, radar is not great. It's basically, if you look at radar and say it's rating light, rating medium, rating heavy, that's about as good as it gets. So don't try to say, oh, that area got 5 inches of rain. There's just too much variability to it. Other challenge with radar for our region is I use Exeter because all the storms seem to come up from the south or from the west, but we're on the outside range of Exeter. The next closest radar is Britt, which is by Perry Sound. We're on the outside range of Britt. And the next one closest is King City down by Toronto, and we're on the outside range of it. So we need one in Tobermory. So, but it's the best we can do. It has its limitations. So just very quickly, I'm just going to summarize out, Get Real Time. It's free and it grabs all this stuff, puts it together. And once it's in an Access database, I can do whatever I want with it for charting and grabbing and summarizing. And it's all automated. So I'm not going to talk much about our flood messaging that we do. Only thing I want to say, if my flood messaging has a W in it, please take notice. Watches and warnings are confusing. So we will put out a watch when we think it might flood. We put out a warning when it is flooding. So, or it's going to flood for sure. So I always remember it as a watch is really a warning, and a warning means you can sit back and watch it. So that's the best way I can remember. If I put out an outlook statement, a flood outlook or a watershed condition statement, it's more just I like to put one out every year during the spring runoff just to make people aware that you should be conscious of the river flows are going to come up. I don't like to put them out every time it rains or every time the stream flows come up because I want you watching for those W ones. I don't want to be crying wolf all the time, and sometimes the media might take the messaging the wrong way. I don't want to become like Environment Canada. Every time they put out a weather warning, everybody goes to sleep. So I want to make sure if something goes out, that you've seen it. And to end this, I want to put an earworm song in your heads. So do you see the sign on the left-hand side? It's a flood level sign. I can't imagine having those. Like I can see historic ones, but just not ones just every time you hit a road crossing. So yeah, that's the end. Thank you. Um, any questions?
Two things maybe not directly related to your work, but I've noticed a lot of standing water in fields this year, more than I think is usual. Is that because we've had rain and melt at the same time and the ground still frozen, or what's happening there?
Yeah. So my understanding is you're noticing a lot of standing water out there this year specifically, and you can quote me on this. It's been wet, so it's now standing water in a field. I'm sorry, as a flood forecaster, I want to see that. I know the farmers don't like it. I want to see water stored on the land. I want to make sure that it's not getting away quickly, because the quicker it gets away, the more issues it causes downstream. So I like to see standing water as long as the houses aren't flooded or basements aren't flooded. But that's actually a good thing. Oh,
Can you explain why the water, from walking at Kelso Beach, and the water was way out, really, really low, and yet the river in town seemed to be its normal level?
okay. So you're commenting about Kelso Beach water being really low, but the river seems pretty good flow. Uh, it all depends on the wind direction. So if the wind's pushing from the west really good, it will pile the water up on the far shore. So it actually pushes it. Um, if it's really, really crazy wind and it pushes, then I think that's called a sake, and it actually can cause a lot of flooding on the other side. So it's the wind. If it's a really windy day, then that can happen. And then when the wind stops, it all kind of comes back. So it'll slosh back and forth for a bit. Like you seen the one graph I showed of the elephant location where the water level is going up and down. So that all comes down to how windy it is. And then at nighttime, it gets calm. The water levels out again. So, and I'm not going to bring in the lunar effect with the tides and stuff too, but that can have a bit of effect too.
I was curious, when you see that amount of water in the farmer's fields, like we have Spring Creek Road just near Sauble Beach.
Okay.
And it was across the road and it was a huge lake. I mean, the whole field was water. How does that affect the field? Like, are the farmers happy about that or?
Okay, so more field flooding. So the farmers want to get on the land as soon as they can when the temperatures are right, so they can get their seeds in. So it can delay them getting on the land. So that's one of the reasons why the farm community wants to tile drain and get the water off as soon as possible, so that they can work the land as soon as they can. A pasture field's not quite the same issue, because the grass will start growing even if the ground's kind of saturated. But it's, again, like I said, it's for me, I want to see that. I don't want to see people flooded. I don't want to see roads flooded, but I do want to see water stored on the land, as opposed to no, because it's fairly temporary. If it's more if it's flooding for longer periods, it can change the soil a little bit. Just depends on how long it's flooded. But if it's flooding now, it's probably an area that floods almost every other year. So yeah, this year is wet. And especially up the peninsula. I know the Rankin system is really high right now. So it's taking a long time to draw down. And the groundwater is all high. The swamps are all full. We got a lot of water out there.
So are the farmers very technically oriented and they're using your data?
The only way I can tell is some of my products, like the Google Maps, will actually show how many views are on there. And during that last rain event, when we were really pushing people to use it, we had 3,000 hits on that map, which is really, really good for our area. The map's approaching 60,000 since we created it. But the rainfall ones and the crop heat unit ones, they're up close to 10,000, and they're newer maps. So we tend to try to promote that we have these things, encourage people to use it. I think people just keep forgetting that we have that. And any one of those links, you can just save it in your browser, and you don't have to go to our website. You can just go directly through the link. So but for the most part, I think people are using it. We don't get any complaints. We get a few compliments. So I don't know how you score that.
You're mentioning on Burford Lake, it's always raining.
Yep.
Is that what happens to Shallow Lake when it's more extreme version of it? Because then you have the audience for the lake's kind of-
Yeah. So the comment is Shallow Lake seems to perform similar to my comments about Burford Lake. And yes, Shallow Lake has sinkholes. It does have a channel that it outflows through, but all summer long it will drain through sinkholes. And again, it's the systems, a lot of those systems are not groundwater fed through the summer, so they rely on rainfall as opposed to evaporation. So it's not uncommon.
What is a sinkhole?
Oh, a sinkhole. So because we live in an area that's mostly limestone, limestone can become soluble, and water can actually create holes in it. And then over time, it just keeps more water goes into it. So we have quite a few sinkholes throughout Grey Bruce.
That's what's underneath Shallow Lake.
It's Shell Lake has,
Water
yeah,
goes underneath all
yeah.
that.
yeah. And like another spot where you might see one is out by the Owen Sound Airport. If you keep going towards Meaford on the right-hand side, you'll see flooding, but then there's a huge sinkhole right there that the water's going into. That's probably the most visible one.
There's one too in south of Purple Valley where I remember on the heights, we had a disappearing
Water course.
river
Yep.
or something. Yeah, just,
Yeah. So they are very common. They are very common around here. And that's one of the hazards that our planning department tries to keep people away from, is to make sure you're not building a house on a sinkhole or a crevice in the limestone that you can't see. But they are very common for us. Who's moderating this?
We'll go right to the back and then we'll
Where
get.
does the water flow in sinkhole? Does it go to an aquifer or does it flow somewhere?
Yes. So where does the water go once it goes into a sinkhole? Multiple places. It could go right down to the aquifer. It could stay in its own little channel and then resurface somewhere almost a little further downstream. I know the road that goes into, I'm going to say Terra, the road I would take to Terra from Owen Sound. The water actually in the summertime is going into a sinkhole on the upstream side of the bridge and then comes out back again on the downstream side. So it could be really short conduit, or it could be contributing directly to the groundwater.
You have another question coming or?
Sorry, yes. What's the water quality like in the Sydenham River in Owen Sound? And what are the pollutants that you find there?
Okay, so what's the water quality like in the Sydenham River in Owen Sound? Probably because you're seeing a lot of algae down there. Are you wanting to drink it, swim in it, or it all depends on what your use is as to how you describe water quality. But I wouldn't drink it because it's a surface water source, so it's going to have E. coli no matter what. To swim in it, it's probably safe to swim in. I don't think E. coli gets really bad there, but don't swim in it after a rain event because all the storm sewers in that area drain into the pond. So if the water's turbid, it's going to have a higher bacteria count in it. Swimming is fine. Boating, and you can boat on top of sewage lagoon if you wanted to, but you need, when you're describing water quality, you need to also describe the use you're looking at. Um, so if you want to drink it, water quality is really poor. If you want to just swim in it, water quality is fine.
This gentleman back there, sir?
You got an official snowfall measurement this year. I wonder if the heat units, if they change much over say, 10, 20, 30 years.
Okay, so there's two in there. There's what was the snowfall amounts for this year, and you just want to know how they compare to historic. So snowfall, it was above average for sure, but it was nowhere near our records for 77 and 78. Those were outrageous. So what it was?
Yeah.
It depends where you were. The way our region gets snow squalls, so we get some areas just get dumped on, and they just keep getting dumped on. Um, yeah, and we don't do total snowfall for the year. We just do what it is at the day we measure. So a lot of times, if we're over 2 feet, that's a lot of snow, like depth, because it does disappear. It shrinks. It evaporates. It definitely keeps compacting down. And just so you know, with snow, new fluffy snow disappears like nothing. But if we have snow that has a bit of a melt, gets a little bit of a crust in it, gets some maturity, that makes it more resistant to melting the next time and can hold more rainfall and stuff like that. So the maturity of the snow also helps us with, do we think this is going to all disappear today? Like they have down south, they will lose it in no time. Whereas we're getting a nice rain event and we're not even worried. It's just soaking it up. The other question was the heat units. So trying to look at heat units over time is difficult when you don't have a lot of old data to look at. So Wyerton's probably and Owen Sound both would have had nice temperature data, but it's just those two locations, and they were both on the water. So as you get away from the water a bit, the heat units can get better in areas, but if you get too high of elevation, then the heat units come down. So it's if you look at the maps that I make, it's really neat to see the variation of the heat units. But just remember, toys are collecting the data, so I can't verify every site, but I can just see the general trend to them.
How important is it to keep water in the watershed? Like when you hear of bottlers, like Canada Dry and stuff, using a whole lot of water. And then I was concerned one time when I was visiting the water treatment place in Collingwood when they built the new one. They were taking water out of Georgian Bay and shipping it down to Alliston. And I thought, is that still in the same watershed? Like, is that
Yeah.
when they get back into Georgian Bay? Because I understood it was important to keep water in the watershed.
Yeah, so there's two parts to that. So you're asking how much impact is taking water for these bottling places, and then and taking it out of the watershed. So we don't regulate water taking, so that's a provincial regulation. They're the one that review it and okay it. If the water taking is less than 10% of what's being produced at the site, they're generally good with the taking. So as long as it's not like a pulse taking where they're drying the stream up and then getting it all at once and just doing more of a trickle taking, it's not too bad. It's not a lot of water when you actually add it up as to what's actually coming out of a system. So when depending if what stream it is, when you start looking at if the stream has 1 cubic meter per second of water going, and they're taking 100 liters per minute, it's not even really even close to what the stream's producing. So, but it's every site you have to look at it and see what's the production and how much they want to take. And then I don't know if they actually look at where it goes. From a regulatory perspective, from us who regulate water courses, we want to keep all the water courses flows in that watershed. Because as soon as you start directing it to another watershed beside you, then you've changed the flood dynamics of that watershed. So all the roads that got built for the last 100 years, where they just put in a culvert big enough to handle stuff, suddenly that culvert might not uh, be appropriate. The old culverts were never studied or sized. They were just, that looks big enough, stick it in. And if it doesn't work, we stick in another one. So that's how your roads have been designed over the years. Now the new roads will all have engineered, sized for pipes, and they'll all try to estimate flood flows. But the old water courses, they're whatever works is what went in. So
I think we'll go last question with this gentleman here.
Go back to the standing water, river, to see rather than water getting away quickly, I was just wondering what disadvantage there are to the water running off too quickly.
So yeah, that's it. Yeah. So the question was, what's the disadvantage to water running off too quickly? And it's just, it goes downstream too fast and causes flooding downstream. So if it's stored upstream and released slower, then you don't get that same pulse coming down. So it reduces the peak. So even just to go that way, even with developments, sometimes a development will say, doing all their modeling, all their math, they're saying, all the water that we're producing is going to get to the system faster than the peak comes. So sometimes that will get approval because it's not going to affect the peak flow, but it's all in the timing. Generally, we want to see water stored on site, but sometimes it's just not possible. So it all depends on the situation.
So we're cutting it down. John, are you coming up?
I'll be quick. It's hard, but John.
I told you, I generate a lot of questions. We'll see you later. Good to see you again.
Move over there.
Move over. You want one?
Yeah, I love that. You can get freebies if you bug them enough. I've had the pleasure of knowing John for a number of years, but I just want to start. Oh, yes. Sorry, John. Yeah. John's an unsung hero. He's one man looking after this damn watershed, from down by Flesherton all the way up to Tobermory. He's responsible for 5 major river systems and hundreds of tributaries. And it's sad because along with John, the rest of the staff at the Great Sable Conservation Authority, we're very limited in the employees. The provincial government does very little for conservation in Ontario. So John, I really chuckled of all the little things he does, using old cell phones, different things. But the enormous task of all that data he's collecting, he does it on his own. And he loves these little creatures. And he's got a little lab in the basement of the Conservation Authority. And unfortunately, it's going to be on hold. As you know, the administration building is going to be shut down for a year. And they're moving the Gray Sable down to the old post office, or the upper storage area of the post office. So John's going to have to give up the biomapping for a little bit and all those little creatures. But he oversees all those programs that he's talked about tonight. Like, it's amazing what one person, he does have Elaine helping a bit and the summer students, but overall, it's John doing the work. He talked about flood warding, because the whole purpose of the Conservation Authority was for water protection, water control, and water protection now has been legislated to the Conservation Authority to make sure clean water is happening. The water quality, he loves that. He checks out he did really tie in, when he looks at these creatures, he can tell how good the water is. And he's good at that. And he loves the report card. I encourage you, not tonight, but tomorrow, if there's some rain, you got to sit around, go to the website. The Gray Sable Conservation website is great. And under his department, water management, he has all those programs and you can go through. And the best thing that I liked was the report card. It's done every 5 years. And the last one in 2023 is excellent. Gives you a whole summary of what this watershed looks like. So John, in short, he's a hard, dedicated worker. He works so hard. He's a loner because he's in with all this data. Holy cow. I would go bonkers with all that data. And so he's looking after all these water systems. But guys like him and other employees in the MNR, MOE,
they love the environment so much and they'll give that extra time. So on behalf of the audience here, I'd like to thank you for sharing all the information and your hard work. And we wish you all the best in your new facility for 1 year. And hopefully when the new building's restored, you'll get more space. So thank you very much.
I guess I owe him that case of beer, don't I? Is that it?
Yeah, that's it, John. Thank you, Dave. As you said, I think the questions kept coming.
Oh, I trigger a lot.
Yeah, so I thought I'd better